Hello, this is Brandon Farr from Level Up Strategies, and I want to invite you into a super important conversation. This is all about Passive House and whether you should or whether you should not build one. See, as a licensed builder a few years back, we looked at the world of high performance construction and we decided that we needed to participate, but we didn't know where to begin. So a few years later, we're certified Passive House designers. We understand some things that we think will be helpful for you. So if you're thinking of building a passive house or you just want to know more about it, this video is for you. And on 2 pages, we hope to clarify everything you need to know to make an informed decision, which path to follow. So jumping right in, why you should build a passive house. You know, for starters, passive house is the gold standard in high performance energy construction. They've been doing it for over 25 years. It's based in Germany. There are brilliant people that have dedicated themselves to understanding building science, how to build energy efficient homes, and then simplifying that for you and I all around the world, because passive houses are built everywhere in every continent. So it is possible in your neck of the woods. And the confidence that you can have when you're looking at building a passive house versus any other organization is that there's some substance there. You're getting reputable. When that badge means something, it's understood all around the globe. And part of the reason for that is that Passive House sets a performance standard for homes, which means that it sets the bar right here. And there are some standards that are high. Well, Passive House is really high. So if you are building a passive house home, the standard is super high and it's recognized for that, but it's also consistent all the way around the world, which we'll get into why that's a drawback later, but it just sets the bar. So if you achieve passive house, you've hit the minimum criteria, which they highlight in their website. And I'm not going to go into the nuances of what constitutes that, but just to say they set targets on what you need to heat for heating and cooling and how much you use per meter squared in your house. So the size of your house, they have limitations on how much you can actually use in a year. They set really tight standards to air tightness, and they have really high standards for the hygiene criteria, which is a safe thing for you in terms of mold and condensation in wall assemblies, but more practically what you're going to feel is thermal comfort. And just to clarify what that means, if you ever walked into like an old school house and it was really warm on one side of the room and you move over next to the windows and you can feel the cold on your arm and you want to move away from the windows because it's too cold to study, there's actually ways to calculate thermal comfort and the difference in temperature in a room. And Passive House says you can't be cold on this side of the room and hot on this side of the room. You don't get to take the average. You get to take real-time temperature in the whole space, which makes it really comfortable for you and I to live in that space. So another really neat advantage of the Passive House standard is that it's super easy to go from that super high Passive House standard to net zero. If you want to offset your passive house with renewables, you're going to be able to do that. And a great way to think about it is if you want to go net zero on your classic home that was built in the early 2000s, you might need a solar panel array that's this big. But if you had a passive house, you'd only need one this big. And that's just a metaphor to go, hey, if it's already super thermally efficient, you don't need a ton of energy to operate it. It's primarily run on electricity, so your solar panel size can be smaller. So it's cheaper for you to buy, it's cheaper for you to maintain, and it's super easy to get to those net zero targets, which we're all aiming for as greenhouse gases and emissions and carbon footprint are becoming more present for us as a community in North America. So, which means whether or not you go net zero, regardless, you're going to have a super low cost on your utility bills because it just doesn't use a ton of electricity. Most of the utilities would be your furnace, your hot water tank, your air conditioner. They might be run on heat pumps. It's going to be primarily electric. Is it possible to do gas? Yes, it's just not as efficient. So you have to hit these standards of energy consumption. So if you use alternate fuels like gas, you're just going to have a harder time to do it because it's not. You can do it. There needs to be compromises in the whole system. You can also get a fireplace. There's passive house rated fireplaces and super thermally efficient and all that. Does it add some complication to this? Yes, but it can be done. So you'll be spending a little time and a little money, but it can be done. So a super interesting piece that is overlooked perhaps for most of us that are used to walking into a house of all shapes and sizes. I grew up in Winnipeg, and some of those houses were giant old buildings with sawdust in the walls and single pane glass and wood shutters on the outside. you're used to walking through a house and there's warm spots and there's cold spots and there's a warm spot again, and then there's condensation on the windows, and we're not used to the just right temperature. On the hottest day of the year, a passive house is going to feel nice and cool. On the coldest day of the year, the whole house is going to feel just the right warmth. Because they're able, the envelope is insulated in such a way, it doesn't fluctuate hot and cold, hot and cold. When the furnace kicks on, it doesn't flood to hot, and when the air conditioning kicks on, it doesn't flood to cold, and when it's hot outside, it doesn't migrate through the house to overheat. It's this just right, beautiful temperature control. So it's a really neat experience that we're not used to, so we might not value initially, but after you've been in one, you'll understand, especially if you get to live in it. And additionally, with the insulation, it's quieter. You got thermal panes or triple pane glass, that the road noise outside, the buzz of a city is all muted, which makes for a calmer environment. All the air is filtered, so it's a cleaner environment. Less allergens, less pollutants, less dust. It's a beautiful thing. And jumping back to the hygiene criteria, when you understand where the thermal bridges are and where condensation can occur in a wall, and you've used their one of their principles is thermal bridge free construction, so you can actually say there's not going to be mold in our house. Like you can calculate the mold out of your house by how you build your wall assembly. So for those that are concerned about interior air quality, this is super important. Now, a big piece for us, the Passive House modeling software. It's the PHPP, Passive House. Oh, I'm blanking here on video. Okay, it's the PHPP modeling software. I'm also a certified Enercan energy advisor here in Canada, and they give us a software called HOT 2000. And there are other softwares out there, and none of them compare to the modeling software that Passive House provides. It is thorough and comprehensive, and it actually represents the finished product of the house, which is one of the major deals. If you're going to go into this whole process of building a net zero home or a super and high performance energy conscious home, and you do all the work of modeling, which you have to do to get a building permit. If you're here in Kelowna or British Columbia with the Energy Step Code, you need to go through the process, the pain and the expense of energy modeling your home. And most software won't produce an accurate reflection of what it will look like in the end. And to be fair, a lot of people know how to cheat the system in the HOT 2000 software so as that you can make the spreadsheet look like the house will perform a certain way, but upon completion, building and occupancy, the house will perform nothing like what they said it would at the beginning. Now, if you're the type of person that just wants to get through the permitting process and get through the energy audit or the energy modeling just so that you can build your home, that's not going to bother you. But if you actually care about understanding what your home's going to do once you live in it, and you are putting the time, energy, and expense into building one of these, I think the accurate reflection piece is super critical, because a lot of people make decisions based on poor modeling software that says, hey, double pane windows will be fine. And in reality, they're not. Triple pane windows is where you need to be, and triple pane fiberglass foam-filled frames is where you need to really be if you really want to have beautiful windows, lots of light, and high performance assemblies. So one of the lists on the 5 Passive House core principles is amazing windows. And there's stickers out there. You go to a hardware store and you'll see these Energy Star stickers, and they're double pane, high performance glass, and it's garbage. They're able to cheat the system based on how they measure the thermal conductivity of the window, and they often measure right in the center, but most of the Windows poor performance is on the edges. And anyways, so people are cheating the system all the time, and that can come at an expense to you. But Passive House doesn't allow that to happen, and because of the way they very thematically look at a building, which is brilliant, so you get clarity and accuracy. And we'll jump down here where it says they also have done the work to pre-qualify a bunch of building materials, the essential parts, the heaters, the air conditioners, the heat pumps, the windows, the doors, so that when you go looking for what do I need for my home, Passive House has independently audited the performance of these windows according to their Passive House criteria, which is super high, which means that instead of those R2.4 windows you might get at the hardware store, you're getting windows with an R value of 10. Like, it's way better. It's not even in the same category, but And they're confirming that it's not cheating or manipulating. It's true to what it is, so that when you install it, it'll be what they promised in all the areas, particularly around Windows, where you can cheat these things. And it's just, there's a lot of confidence as a consumer when you follow this pathway. Now, along with the modeling software, a neat part about building a passive house, as distinct from just going to a high-performance home that you're gonna do the work of the high-performance home, is that municipalities actually acknowledge a passive house as a credential. And what that means is, in Vancouver in particular, Vancouver, Canada, the municipality actually gives you some allowance. Because when you take a lot, especially if you're going to infill a lot, there's existing buildings on both sides, and they have what's called setbacks, so that you can't touch your neighbor's house. There's got to be space between it. And there'll be differences in terms of what municipalities want between homes. But they've actually made exceptions to lower the setbacks and offer more variance in terms of height and width to passive houses. Why? Because the walls require more insulation. And so the city says, hey, we're not going to put you in a box and then make you get energy efficient and squeeze you on the inside. We'll acknowledge that you're actually trying to do something really special. It's going to help our environment, so we'll give you the same room on the inside, and we'll give you some extra tolerance on the outside, which all works to your advantage. You're not shrinking your square footage as a penalty to energy efficiency. You're actually getting a boost. Same thing, so you need more attic insulation. Think R40 walls, R60 ceiling. That's kind of a ballpark of where you want to be. And there needs to be foundation or insulation under your foundation as well. So the pre-qualified building materials is just a really neat resource. They have a database for you. You can search by country. You can search whether you're looking for HRVs or ERVs, which is the lungs of a building that flow air in and out, and the hot air passes off to the cold air, and they blend the temperatures, so you're not wasting energy by pulling cold air into your house in the winter and then having to reheat it again because you've already heated air. So they exchange that heat. It's beautiful. But perhaps one of my favorite parts about a passive house, and why, especially if you're in the used market, like you're going to go buy a home that's built, is the deep consideration that has gone into the home in order for it to become a passive house. I'm going to go so far, like I'm a licensed builder, so I'm going to go so far as you cannot become a passive house as an afterthought in building construction. You can't give me your set of plans that you had drawn up last month and you're like, okay, Brandon, I love hey, can we make this a passive house? We can't do that. There needs to be deep consideration from the planning stage with your designer. They have certified passive house designer consultants. That's why we went through the process. Is you need to be integral in the way that the house is built, with the type of wall assemblies, where the windows are, the overhangs, things like this, to make it actually hit the standard. Then throughout the building process, you need to be actively engaged in maintaining the standard that you've outlined in your modeling software, so that people aren't poking holes in your wall assemblies and therefore compromising the airtightness criteria that's super important to this. And I know a builder, and he's an extraordinary builder. We're talking on the scale of like 10,000 square foot homes that are passive house caliber. And his whole philosophy for tradesmen on site is no utility knives, scissors only. Because how many times, and you're cutting something on paper and you just slide over here, and this becomes a casualty of what you were trying to cut here. And when you have airtight membranes in the house, you have really fancy tapes, you've gone through the work, you don't want anybody accidentally compromising something that just can't be patched up, because you're looking for seamless continuity of barriers. So anyways, scissors only on his job site. And I respect him for that, because he's maintaining the standards of high performance throughout the build. Because it's all audited at the end too, audited in the design, because you have a third-party auditor, then it's audited in construction. You have to have trades training as well, and then it's audited upon completion to a higher degree than any other standard is audited. You have to do a blower door test in both directions, because what most people don't realize is that when it's hot outside and cold inside, think summer, the temperature gradient pushes into the house. So it's kind of a suck on the assembly. So if there's air leaks that flap open, when it's drawing in, air can exchange. It leaks in. But what happens in the winter when we heat the inside and it's cold on the outside? Well, then it actually pushes out of the house that way. And if there's a flap that's open on that pressure gradient, it'll leak out that way. Now, so if you have it this way in the summer, it might feel like it's sealed, but in the winter, it opens, and it does that. It's just, that's why they pressure test in both directions, to make sure the seal works all year round, so you don't have differential performance. Anyway, so all that to say, at the end of the day, you get clarity, you get accuracy, and you get a super high performing home guaranteed. It can't be Passive House if it doesn't meet the standard. Standard plus 1%, no cheating, doesn't meet it. So that's the why you should. But why shouldn't you? Let's take a look. I think the first barrier most people will bump into is the cost. There's the cost of high performance construction. Can that add 15, 20% to your home? Yes, absolutely it can. Materials are more expensive. Triple pane glass is more expensive than double pane. No two ways about it. But if you're in the category of I want to build a great home, and you're thinking, hey, do I want to go Passive House or not? A couple extra costs are, you're paying a designer consultant in the planning process, but you're also paying an auditing fee. And these aren't cheap. I mean, is this $20,000, $25,000 depending on the size of your home? Yeah, and that's just an extra cost. And if somebody's maintaining the standard and they're auditing the standard, and you've had sloppy trades or a builder on site that's not considerate, they call them air barrier champions, and you specify the house, you paid the planner, you paid the auditor, and your tradesmen are sloppy and they poke a bunch of different holes, and you go to the end your project, you do a blower door test, and it doesn't achieve the 0.6 air changes per hour that Passive House requires, it doesn't pass. So you can pay for all this process, but if it so there's cost of I'm going to say continual auditing from qualified trades and your builder through the process, with just more time and attention, which is that consideration value. But that does add expense because time's not free when you're dealing with quality trades. And on the trades part, some trades, especially the non-current ones, if you say Passive House, hey, would you help me do my drywall on a Passive House? They go, I don't want to be involved in that. Because they might perceive it like we did, honestly, going back in time. Several years back, it felt like an onerous burden to like jump over these extra high hoops. And there's a psychology that's a carry forward from a long time ago, that's energy efficiency is a pain in the butt and it doesn't make sense and it's not worth it anyways. And they might actually be afraid of having to perform to a standard as high and clear as Passive House. They might not want to be as tight as is required. So if you're in a place that is a hard time finding qualified tradesmen, this will just add complexity to that journey for you because the number of trades might shrink. But that being said, the most current trades, the ones that you actually want on your site, they're going to be pumped to join a Passive House because these are like portfolio worthy projects. If you are Passive House capable as a tradesman, you're top tier, you're A+. It's just, so there is this nuance. You're going to find people that are, yes, absolutely, I'll prefer you, but I think generally still the feeling in the market, at least from where I'm seeing it, is there's still some reluctance to do anything, even high performance. It's not, I want to build a net zero house. You might get the same kind of freak out. I'm using that as a general term just to say reluctance, apprehension, because there's not a lot of understanding here. And that's why we've gone through this process and why we're making these videos. The education's super critical so that we can actually change the minds of people to embrace what is a beautiful opportunity for us and something we can totally do. But interesting irony here, it's harder for small homes to become Passive House than big buildings. So if you have a 10-unit condo building, if you have a Walmart-sized building, it's actually easier than if you want to build a carriage house in your backyard, which is ironic. And that has to do with how the square footage is calculated. There's square footage and volume and the energy density required. Like if you build a home that's 100 square feet or 3,000 square feet, you need one furnace. And one furnace uses a certain amount of energy. Your hot water uses a certain amount of energy. So it's kind of like this minimum thing. And your windows and doors are less thermally efficient than your walls because you don't get an R40 door, but you might get an R40 wall. Well, a small house and a big house has a front door and a back door. And it's like, so you're dealing with these inefficient zones in a much smaller square footage, which actually penalizes your energy utilization. And that's just real. It's unfortunate because you're thinking, oh, I'll shrink it and make it more. Is it more efficient? Yes. Is your overall energy consumption of a small home better than on a giant home? Absolutely. But the density is higher. And Passive House standard is oriented towards density. And we'll get to this. we'll get to this. And this because here's your limitation based on your meters squared, like your square footage. Think if you're in the States, that's okay. Meters squared is like yards squared. And so which means that there's some limitations in terms of the shapes, the sizes of features, the sizes of windows, and the type of features that go into a certified passive house. If you love lots of windows and an open fireplace, that might just be the thing that makes it so you can't quite hit this performance standard of passive house. And so you get to weigh out, it's like, what do I really care about? Doesn't mean you can't have a really, really, really efficient home. And I wrote a blog where I'm like, so if this is the standard, you can't use more than 15 kilowatt hours per meter squared per year, okay? And you end up using 16. You don't get the standard. Do you have an amazing home at 16 kilowatt hours per meter squared per year? Yes. Are you well below industry? Yes. But does it meet passive house standard? No. So you're not going to get certification, even if you have an amazing home that is also very reasonable to offset net zero with solar. Just saying. And while we're on this, and this is real for me, and I'm sitting here, licensed builder, been doing this for 15 years. Like I understand buildings and building science, and I care a lot about homes that last a long time and are beautiful, all this. And I look at this and I'm confused. I just 48 and a half inches makes sense to me. 15 kilowatt hours per meter squared per year. Like it's not tangible, which I think is one of the barriers to this whole thing about energy efficient homes, and some of the measurements we're using about, and like, why is the K lowercase and the watts is uppercase and the hours is lowercase and meters squared? It's daunting. And I think this is one of the reasons why people won't build homes is it's intangible sometimes when you're trying to hit this target. I actually don't know what this means in real life. I'm being honest with you right now. Like, what is 15 kilowatt hours per year, my lived experience when I walk into a home, versus 16 versus 20? I couldn't tell you intuitively. I'd have to go to the calculations and see the energy utilizations. Or if in your home, the home you live in right now, you need to look at your utility bill and see how many kilowatt hours per year you use based on last year's utilization, and then divide that by your square footage or your square meters. And that's how you and I would get the answer, but there's no intuitive here. And I see that as a genuine barrier to trades, barrier to homeowners, barrier in the planning department, because, just saying. I can look at a wall and go, there's enough insulation in this wall. This is what we need to see. This is too small. This is totally, like, I can see that intuitively just by there's a tangibility to going, not good enough, close, definitely good enough, that this doesn't offer, unfortunately. So moving into flexibility, this rigid performance standard is based here, and it's here all the way around the globe, and there's no flexibility based on geography, which means that people in California or Seattle, Washington are going to have a much easier standard with this, okay? Because how often are you turning your furnace on full blast in Seattle? Now, there's the inverse of this is air conditioning. So if you're in Arizona, you're going to have some challenges hitting your cooling demand because it's a heating and cooling standard, okay? So there's inverses here. But all in all, the heating demand climates, which is like all of Canada, it poses some challenges. So if you're in Bismarck, North Dakota, which is right under Winnipeg where I grew up, it's like, it's cold, and it's cold for a long time. So if you're going to hit this standard in Seattle, your wall assemblies can be this thick. If you're going to do it in Bismarck, you're out here, which is like 8 to 12 inch thick walls of insulation, which is a lot. Now imagine if you had to go from 8 to 12, okay? So that's 50% increase in insulation cost. What are you going to have to do to your windows? You're not going to be able to get away with, I'm going to say, a low performing triple pane glass. You're going to have to go to a high performing triple pane glass. Now all triple pane's high performing for the most part, especially if you're in, I say the fiberglass foam filled insulation, because there are people making low quality triple pane glass windows, selling them as super high performance, and you're a homeowner going, oh, I got triple pane, and you got crap because it's wrapped in vinyl or something like that. So it ends up not performing because all the energy is leaking through the spacers and around the perimeter of the frame and all that stuff. So anyways, if you go to, this is just a hack. If you're getting a triple pane glass with foam-filled fiberglass, no manufacturer is going to go through the effort of manufacturing that assembly without doing the diligence of making it good. So it's a way of kind of setting a minimum for yourself. You don't have to go onto the Passive House website to get pre-qualified building materials if you don't want to. But if your local manufacturer distributor is selling a fiberglass foam-filled triple pane glass assembly, odds are it's a high-performing assembly. Maybe you're getting R8. Might not be R9 or R10, but you're getting at least R8. So as just a rule of thumb, I'm not looking at your data sheets on your window assemblies, but that's part of like that intuitive guide to know if it's the right fit for you in the field, because you got to make a lot of decisions on this stuff. So no flexibility based on geography. If you want to go to Alaska, if you want to go to the Yukon, understandably, more insulation, more complexity, bigger walls means more lumber. It means more insulation, more complexity. Like, how do you hang 12 inches of insulation off the outside of a building and then put cladding on the outside? These are real construction challenges that are geography based, which are required in order to hit this performance standard with this maximum. So there it is. Now, there's hope. There's some space here. You know, FIAS, Passive House Institute of the United States, does offer some regional flexibility. And just, I'm going to wave my hand and say I am a big fan of this, because there's already enough obstacles to getting the idea of net zero high performance homes to mass market. And if you just make it feel like it's punitive to people, it's just harder for some people, it feels unfair, I think that's going to add another barrier. There's already have to pay for the cost and complexity. So let's make it realistic so that, the guy that builds a 16 kilowatt hour per meter squared home is rewarded for that, for saying, well done, you're rocking it. We need more people like you. Tell your friends and family, your whole neighborhood, let's do this. We need to get, because he's in Bismarck and he needs a little bit more time on his furnace. It's like, let's reward people for taking these steps. And FIAS does that. There's some flexibility. And I'm not FIAS certified or anything like that. I'm a big fan of what they're doing because it feels more realistic. Sometimes these standards can feel punitive, and I don't like that. We don't need that sense in the market. Net zero, this is the big one. If you're in business, this is like, if you're a developer or you're in trades or you're a contractor, I want you to understand that net zero is the language of the industry. And because I started with Passive House because it was the gold standard, and then got into it and realized that Passive House is akin to like Tesla 10 years ago. It's like, oh yeah, they're doing it over there, and it's like, it's awesome, but it's not mainstream yet. It's an elite standard, and it's the gold standard. Okay, so that's awesome. But net zero is what the governments are using, what municipalities are using. It's what people are starting to, I want a net zero home, or at the very least, I understand what it means. Net zero doesn't require you to understand this. It just means that if it's 15, you make 15 and you spend 15, net zero. If this number is 87, you make 87, you spend 87, net zero. So there's a sense of intuitive understanding present here and that's why the language around net zero is it's just where it is, it's where it's going. Doesn't mean municipalities don't honor Passive House, because municipalities perhaps understand more inclusively what it is. But this is where the orientation is currently. So just be aware of that. And a big overarching thing here is, like, technically, you don't need certification to have an incredible home. I think it's one of the biggest drawbacks to building a Passive House and going through the extra expense is, like, you're going through the extra expense, and at the end of it, you get the consideration throughout, but then you get a plaque. It's a little plaque that says Certified Passive House Home. You get to put that by your front door, and you get to be proud of it. But you don't need that plaque to have you could have a Passive House that's not certified, and it's still all the benefits of the Passive House. And did you save the certification costs? Yes. Note that if you save the certification and auditing expense, you also save that auditing, which means that you didn't get audited, because you're going to have to pay for that auditing so there's a chance that in the design phase, some of the thermal bridging would be missed, which is just one of those really important parts of building a high performance home, is a thermal bridge free construction. Your balanced heating and air conditioning through HRV and ERV, which is a heat recovery ventilator, energy recovery ventilator. Those might just get missed or not as thoroughly calculated, which kind of puts you back into that, PHPP modeling software. It's the gold tier, and auditing helps guarantee that. So just know that going into it, and decide if that's if you're comfortable with the compromise or the ambiguity. But regardless of what you do, net zero or not, I'm sold, and this is what we do, this is where we are, is that Passive House is a great guiding foundation. If I had a client who says, I don't want to get certified in Passive House, I want to build a net zero home, perfect. We're still building with this in mind. We're still using PHPP to model it, because the software is a standalone. It might not pay for the auditor to do it, but we're going to use this foundation because it offers clarity and accuracy. They can guide you to materials, and they're going to set the benchmark that you can weigh others against and see where the gaps are that you're willing to accept. So I have high honor for these folks. They don't get paid selling products. They're not hustling you and I. They get paid to sell training because they're passionate about it and they've dedicated their lives to this. So lots of honor due for these folks. But hey, listen, I hope that helps. I did it in 2 pages. This has been a years of journey and study and practical field application and whatnot. I'm like, hey, let's make this clear. This is why you should, hands down. And hey, this is why you shouldn't. All the best. Have a great day.